Hi guys, today we're looking at exponential equations. So this is most applicable most of the time when we solving for x or when we're solving for a particular value. So let's look at this first example here. In this case, we're saying this is our example 1. So we have 3 to the power x, this is x plus 1 is equal to 9. Then we want to solve for x, right? So we can say that therefore, if you're looking at this, we can say we have 3 to the power x plus 1. So we can easily change our 9 to be 3 squared. So when bases are the same, we can equate the exponent. That therefore, we can say we have x plus 1 equal to 2. And in this case, we can say that therefore, x is the same as 2 minus 1, hence x is equal to 1. That was our first example. Let's look at our second example. This is our second example. In this case, we have 2 to the power x minus 2 to the power 4 minus x is equal to 0, and we will have to solve for x. To solve for x here, that therefore we can say 2 to the power x is equal to 2 to the power 4 to the power 4. So I will have to erase that. 2 to the power 4 minus x. So we're taking that to the side. Normally it's called transpose. Some people they use the word transpose when you're taking a term from your right hand side of the equal to sign, and you're taking it to the right hand side or right hand side of your equal sign. So sometimes they call it an transposition. That therefore, because you see our bases are the same here, of which is 2, and we have 2, so we can equate the exponent. Hence we have x equal to 4 minus x. That therefore we have x plus x equal to 4. That therefore we have 2x equal to 4, and we divide by 2, and we divide by 2. Hence our x is equal to 2. Okay, so that is how we deal with these equations. So let's quickly look at our next example, of which is example 3. If we're looking at example 3, let's look at 4 equal to 2 m minus 4. So we have to solve for m, and in this case we can say that therefore we can need to change our 4 to put it as 2 squared is equal to 2 to the power m minus 4. So the bases are the same. We have managed to get our base the same, so we can equate the exponent, and then in this case we'll have 2 is equal to m minus 4. Hence we have 2 plus 4 is equal to m, and 6 is equal to m. So this is our solution as well. Okay, so let's quickly look to our fourth example. So this is our fourth example. In this case we're dealing with 3 to the power a plus 5 is equal to 14, right? So that therefore we want to solve for a. In this case we'll have a to the power, so 3 to the power a is equal to 14 minus 5. So that therefore we can say 3 to the power a is equal to 9. That therefore we can say we have 3 to the power a is equal to 3 to the power 2. That therefore our a is equal to 2. So this was very short. So this is how we approach it to done. Let's look at let's look at this one. This is example 5 or problem 5, where we're looking at 5 to the power c plus 1 is equal to 120, 126. Okay, that therefore we have 5 to the power c is equal to 126 minus 1. That therefore we have 5 to the power c is equal to 125. That therefore we have 5 to the power c is equal to 5 cube, meaning that we have c equal to 3. So that was short as that. Let's see if we can find something else. Okay, let's try to find something interesting here in this example here. This is very interesting because we're looking at 1 over 9 being equal to 3x. So what do we do now? This is an introduction of fractions to our normal problems that we have been doing previously. So let's see if we can say we have 1 over 3 squared is the same as 3 to the power x. That therefore we can change our fraction to 3 minus 2 is equal to 3 to the power x. That therefore, because always when you have 1 and then you want to change from fraction, it changes the exponent to be negative, and then in this case we'll have minus 2 is equal to x. Okay, maybe let's look at something more similar to this. That is 5 to the power x is equal to 1 all over 125. So we know that therefore we can say we have 5 to the power x is equal to 1 over 5 cube, and then that therefore we have 5 to the power x is equal to 5 to the power minus 3, meaning that our x is equal to minus 3. Okay, so what we're learning here is that if we have 1 over let's say 1 over a, this is the same as a to the power minus 1. If we have 1 over 2 squared, this is the same as a to the power minus 2. So if we have 3 over, let's say, x squared, this can still the same be as 3x to the power minus 2. Okay, thank you for watching the video.